Hello, hello, hello. Hello, Caritham. Doo-doo-doo. Neuroside. Well, hello, Neuroside. How are you doing? How's it going with flow control? Oh, if you indent it too much, you lose syntax highlighting. Right. Okay. Too much vacation time. Ah, that's fine. Could be worse. It's a good problem to have. Cryptocode, hello. Hello, hello. Hello, everybody. So today you're in for a interesting stream, maybe. We've been doing some development work on D2, and Johnny has helped a lot. Yesterday we had like a very intense day of he has written like a ton of stuff, and then I tried to add Opus to it, and then we were looking at the problem from different perspectives, based on I guess our respective experience, and so we were trying to make things work. And we did make some progress. I'll show you what we have working right now. Also, as you can see, I'm sweaty. My glasses are fogging up. Oh my god. So we had, we tried to make things work. I think at some point I kind of lost steam, and so I felt that the code was a little bit overwhelming, and I couldn't. At some point, I couldn't make sense of it anymore. It was really hard to make progress. But I slept on it. I ate, and now I'm powerful enough to go fight that code. And I think I know. I'll show you what the problem is right now. Like where exactly where we stopped, and I think I know also how to make progress from that point forward. So let's see. Oh my god, this glass is fogging up again. Oh my god, I'm so sweaty. God damn it. Okay. So here's what I would say. Phil Masticot, hello. Here's what I would say. Okay, give me like, I don't know, a moment to stop having my glasses fog up. So give me a couple minutes more. And then I'll be back. You know what? Maybe I can take this opportunity to make myself a cup of tea. I did say that the stream was starting and I was making tea, but I lied. I wasn't. So I can go do that now, I guess. And in a few minutes, I will start. In the meantime, enjoy the packaged version of Opus that we have on all your code base. Mostly made by yours truly. Johnny helped also. There were definitely some things that about porting projects that have amazing build system that I learned in the process. But man, this thing is so simple. We haven't packaged all of it. We packaged basically only the stuff that I need, which is like the core plus floating point, float 32-bit support. But still, that's It's not bad. It's not bad. That was a smooth experience. Okay, so let me go unfold my glasses. I'll be right back. Okay, I'm back. Okay, so here's the situation. Here's the situation. And to show you the situation, I will, you know what? Let's also do this. Oh, so no more having this thing go back and forth. Also, why is this not working with the... Why does it not work with this? Okay. So, okay, silence. By the way, if anybody is watching on YouTube, you're out of luck because on YouTube, you're not going to hear anything because you don't hear sound coming from my computer. Sorry. So you might want to switch to Twitch for that. Okay, I have a server running. Here I have a client running. I can connect to a voice chat. And the idea is that the voice channel, the voice channel will echo back my own sound. Normally, you don't want that, but for testing purposes, the server is running with the echo and the echo flag. That's what it does. It enables echoing back your own voice to you, so you can test by yourself. So there's no more music. I'm still fogging up. God fucking damn it. So people who have seen previous development work have seen that we were playing music whenever you joined. You don't play music anymore. Now we're wiring in microphone stuff, but things get dicey because it's real-time audio now, and you will hear now what the problem is. And let me also bump up the volume from my computer. Okay. Test. You can hear, right? It kind of works, but not quite. Okay. So this is the situation. It kind of works, but not perfectly. Now, what's the problem? The problem is, well, actually, I don't know 100% what the problem is. I have some hypotheses, but I don't know precisely if I'm right or wrong or what. And apparently, it's not that easy to get a hold of this stuff, like understand what's going on. I would be interested actually in probably doing some development work and then stop and take a moment to implement like some observability tool to understand what the situation is. Because without that shit, like you're going in the dark. In any case, here's my current theory of what's going on. Yeah, never mind this complex graph. Let's make another one. I think that the situation is this. Maybe we can also resume the original music. But you know what? Yeah, let's do it like this. What's the high-level architecture for now? The high-level architecture is whenever you join a call, you have two threads that get started. One for the microphone. Actually, no, that's one thread, basically. But let's imagine that there are two separate threads. One for the microphone and one for your, let's say, speakers. So your microphone callback gets called every few hundred milliseconds. And that writes into a ring buffer samples from the microphone. Then there's another thread, let's call it writer, that reads from the ring buffer and sends over the network to the server. Reads from the ring buffer, sends to the network. I guess we're missing only one thing. This is done. This gets compressed with Opus. So this is PCM data. This is Opus data. So it's compressed. Opus is a codec that compresses samples. PCM is kind of like a wave file. Why the ring buffer? Why not the ring buffer? You have to desynchronize things. You have a reader and a writer. They are completely desynchronized. You don't want to have the microphone callback to do networking because you can't stop. You don't want your audio thread to stop to do networking or any kind of syscall. So you need some intermediate buffer, and then if it's a ring buffer, if it's something else, that's like a secondary concern, I would say. Yeah, decoupling. So the server takes your Opus data, sends it back. There is a reader thread, which, guess what, writes to another ring buffer. And then the speaker thread, whenever it gets invoked, when the speaker callback, to be precise, whenever it gets invoked, it pulls from this other ring buffer and sends this stuff to your audio card. I guess we could say this is OS. So this is the rough architecture. The constraints are, well, the network kind of sucks. Well, right now this is local, so it's actually, do you plan to handle clock drift? Yeah, I need to handle all this stuff. Right now, I don't know how yet because I have no experience doing this kind of work, but I want to learn how to do this stuff. Here's the tool that we have at our disposal. So these guys, these callbacks, this guy here and this guy here, they get called on a cadence. So every, I don't know, 100 milliseconds, every few milliseconds, they get called. Have you read the WebRTC specs architecture stuff? I am not using WebRTC, and I don't want to use WebRTC. The problem with WebRTC is that it's like a box. I don't know, maybe they describe some of the contents, but I mean, I read how the WebRTC protocol works, but then they want you to use libWebRTC, and I don't want to use libWebRTC right now. I want to actually learn how this stuff works. Like WebRTC is very high level. Like it does all of this stuff that I described here and more, all in one big black box. And that's what I want to avoid. As I was saying, tool at our disposals, like the, I don't know, landscape. Audio callbacks get called at a fixed interval by the OS. Actually, I don't know how fixed it is, but it's like fixed-ish. Every time they get called, they have to provide some samples, and it's kind of like it's do or die. When they get invoked to provide some samples, that's the moment where they need to provide those samples. If you have them, great. If you don't have them, maybe because let's say that you lost connectivity, for example, then you have to figure out what to do in that case. And figuring out what to do means stuff like make up some silence because you don't have data, or you are falling behind for some reason, and like you now are starting to accumulate data from the network because, I don't know, a glitch happened that made your computer lag for half a second. Let's imagine that. And now you're basically, to play audio continuously, you're now falling behind half a second compared to real time. You can do that, but now you have half a second real time clock drift. I don't know if that's what Neurosite was referring to specifically. I think the clock drift happens without big lagging. I think it happens naturally, things going out of sync, like without catastrophic events happening. But in any case, yeah, you have this problem that basically your buffer could either basically run out of data, so you don't have anything more to play, and then you have to decide what to do, or you could have too much stuff to play. Now you're falling behind, and to play it at 1x speed, it means that you'll always be a bit far behind. And so you need to do things to fix these problems. You need to somehow act. In any case, this is a high-level problem. Then what other problems do we have? Well, no, I wasn't explaining problems. I will explain the situation. So these are callbacks that get called at a fixed interval. Reader and writer, they can block and synchronize over the ring buffer. So the writer can just literally, have a condition. I use a condition variable to sleep over the microphone ring buffer to wait for it to have enough data, and then only when we have enough data, we consume it and send it to the server. Reader obviously blocks on the network, waiting for more data to come in. Other things at our disposal are what is not pictured here is that this connection, these two connections here, these are SRT, which is it's a UDP protocol with a bunch of real-time stuff added on top that we are not leveraging. So we need to learn how to leverage all the real-time properties of SRT. So that's another thing at our disposal. Now, here's what I think. And I think that with this guy in place, handling clock drift and all that kind of stuff should be pretty easy. I feel like very optimistic about SRT. Now, here's here's what I think is the current situation. I think that the current situation is like this. There's a timeline. The audio callback gets called at fixed intervals. I think it gets called every 100 ms. Opus operates at much smaller windows. Opus operates at 10 ms windows. I think what's happening is that currently this thing gets called whenever. And by the way, I did have previously, I had an implementation of this code that didn't go through the network, that was doing local playback. So the audio thread would read from the microphone, and instead of, well, I guess I can show you from with the graph. Oh God, what am I clicking? Basically, instead of going through overall the network, the idea was, oh, microphone reads, compresses with Opus, and immediately puts here. So I had this set up. And with this setup, so basically, just simplifying everything. It's like local echo playback, but with Opus in the mix. By the way, I also haven't specified it, but yeah, we do put Opus in this thing. We give Opus to this guy, and this guy then does Opus to PCM, like uses Opus to decode the bytes. So with this setup, everything was working fine. I wouldn't hear like any form of lagging. What I think is happening right now is that our setup is such that the callback gets called, but when it gets called, we have like acquired like 50 ms of data. And so what we do, we don't have a concept of saying, oh no, we should wait more. We are just starting and we should wait for the buffer to fill first. We just immediately play these 50 milliseconds and then put silence in the remaining ones. So this becomes like this. And the problem is that then we get here, and here we have another 50 milliseconds. And then we again play half of those and then silence. If only we knew to wait more, like we could wait one full thing where we don't consume anything. So we play 100 milliseconds of silence as the audio starts buffering. Then if we did that, we will get here with full 100 milliseconds of data, and then full 100 milliseconds, well, hopefully, of data afterwards. So I think the problem is that we're just going out of sync, and our code doesn't have the concept of, as we are starting, we can delay starting a little bit as to wait for our buffer to fill. That's, I think, what we need to implement, basically. Yo, Neurosite! God damn it. So if you know this stuff, man, you should get yourself more involved. I don't know shit about this. I'm like figuring things out from scratch as I go, like a peasant. Please share your wisdom with us. Could just delay calling the start function on the audio stream. Yeah, but I don't think that's. I don't think that's something. How can I say? I think that the concept of saying we have a buffer, and as we are starting, so if we have a flag that says we haven't played any audio yet, or a disconnection has happened, so I think we need this should be a mechanism that also could be re-employed whenever there's a big disruption. Whenever there's a big disruption that causes us to cut what we are playing, then every single time this happens, we want to wait for the buffer to refill before we start playing it again, I would say. With maybe some caveats. I don't know, maybe there's some more logic that needs to be added for pathological cases. But yeah, so I think this is a mechanism that definitely should be employed at the start, but probably should also be employed whenever we are in the condition of not having to preserve continuity from a previous set of samples that we were playing. Right, I think there's like two modes. You were playing something, and now you have to continue, and so now you have to decide what to do, which is basically try to preserve what you were playing before by adding silence, ideally in a nice way, or yeah, that's kind of what you have to do. Or you can decide to kind of straight up interrupt, like give up. And then there's the second mode, which is you haven't played anything yet, so now you have the luxury to wait because there's nothing for you. You're not gonna ruin anything. Yeah. Yeah, I think it's worth. I think it's worth implementing this no matter what, because the out of sync stuff, like it is just a theory. I agree, but it seems very plausible because there's nothing that keeps these things in sync, and our code right now is, very, very serious about this. Oh, you know what is another way to test this hypothesis? You know how we have the thing where we play the audio and then we add the silence afterwards. If we add the silence before, that would fix it. That would also introduce other problems. So it would cause other trouble. But yeah. Yeah, that's what's nice about SRT is that it gives you timestamps. For every sample that you're receiving, it gives you when it was the intended time, when it was the real time for the server. And so you can use that information to also guide your decision making. Okay, so let's do some of these. Okay, so here's the idea then. Audio stream open. We have the audio callback capture. This reads from the microphone. So nothing to change here. This plays out stuff. Okay. I also, Johnny, I think I came to the conclusion that I think it's okay for the network to decode Opus. And I think that the playout callback should basically operate on a sequence of samples plus knowledge of the timestamp. Like basically it should be like a ring buffer, but you know what the timestamp is of the current head, meaning like we played up until that time. And then you can do logic based on your current new time. That kind of stuff. And what I'm thinking also is that probably you can have this thread introduce, call the decoder to ask for empty packets to produce, nice silence. Well, not exactly silence, the robotic stuff. And I think that should play nice with the rest. I don't know for sure. It should be tested. Okay, in any case, enough theory crafting. Some coding. So this guy has all its information inside this playback buffer, which I think we wanted to change everything to play out. Johnny uses the word play out for things, and we're aligning to that. So we have this playout buffer. This playout buffer has the ring buffer. And the idea would be, once we do implement it, is to add here also the information about timing, but we don't have that for now. But at least let's add a flag that says something like we started. We just started. We haven't played any audio yet. So let's call it like this. Preserve continuity starts at false. And it becomes true after we played something. So preserve continuity starts at false. Nobody has to touch it. This is for us. The second problem is, right now that buffer contains Opus data. And we don't want that to contain Opus data. I think we want that to contain samples. So let's change also that to contain samples. Okay, so now we need to change some things because the decoding, let's gut this function. We'll think about it later. The decoding now has to happen from the reader thread. Media receive. Yes, media receives a packet, but now it doesn't write it down. Instead, it decodes it before writing it. So let's see how this works. Length is the length of what we just received. Declan. Whiles of Opus packets, that's also not a thing. We don't read anything. We do have a buffer. We already have a buffer here. Oh no. PCM buff. PCM buff. And want to decode. Want to decode this message. Starting from 1, because there's 1 byte. Incast received -1. Wait a second. I think this is wrong. Okay, so the problem is that whenever we receive a message, there is 1 byte of data. It's like a framing thing that's not the Opus packet. So I want to skip that. Why was I doing the subtraction here? Oh, right, because we were writing the length in the thing. Yeah, no, we don't do that. So this is the length from 1 to len. Yeah. Do we don't need to accumulate anything, I think. Okay, let's see. We have PCM buffer. We write in there. The code float in an MPCM. No, never mind. So these guys are flipped around. So input is buff. Let's call it like in. One through len. Then PCM is gonna be this guy, PCM buff. Oh, I guess we can call it just PCM at this point. Okay, so with this, with the code in PCM or input, this might need to be bigger. We'll see. After we have this, we need to write this in the ring buffer. So playback buffer.write slice or something. Dot samples. Write slice. PCM. Okay, and then what do we return? That's what we did before. Now we don't have to return anything. So we have to write slice. Now the problem is that we don't have right now any logic for deciding what to do when the ring buffer is full. So for now, here's what we do. Catch. Play out ring. Hey, JavaQ, hello. Good afternoon. It's been a while. Nice having you here. That's low latency. What is low latency? You mean this buffer size? Oh, the stream. I see. Sorry, it's just because I happen to be doing a real-time audio stuff. By the way, I don't know what I'm doing. I'm learning stuff as I go, but that's why I got confused. Okay. Let's see. So play out, ring buffer full, dropping. Okay, dropping sample, sorry. And that's it. And that's what we keep doing. I'm not locking it though. We're missing some blocking logic. Playout buffer has write. Oh, it did have write. That has locking, does the checking instead of YOLOing. You know what? That's perfect. And that's it, right? Does it? Yeah, it basically it hides the failure condition from us, but it's fine, whatever. Okay. So with this, we are decoding on the fly. We are writing stuff there. That's perfect. There is the fact that we're not protecting the decoder with a lock is a problem. Let me write a to do for this. Okay. Just left it there for the future. In any case, so we do this. Let's increase the size of this thing, maybe also. Then so now we're writing samples to the playback playout buffer, right? We want to also change this to playout. Playout buffer. Then how to call back playout. Now wants to get this. Inside mutex get frames. Why were we locking it before? Oh, because we were using... Yeah, well, no, why were we looking at it before? Hey there, Toyfield. I think this can be put inside that function. Just call it read. Let's just call this read. And I guess we pass a sample to it. Sorry, we pass the buffer to it. Okay, let me think. In the case where microphone and Opus audio settings like sampling rate, channel interleaving, sample format matches 1-to-1, then you can immediately copy into there. But in a more generic case where these things are not perfectly in sync, then you need to have a conversion step. So I guess read should do this. I guess the assumption is that read is given... yeah, but then how you describe this? Because this is not going to be F32s anymore. So I guess we should talk in terms of array of bytes no matter what. We just keep passing around array of bytes and then like, fuck it, this is it. Or something. Or you make this an any type. And then some of these guaranteed with Opus. Oh yeah, for sure. No, for Opus, we totally hard-coded the settings. Opus is always going to be running at 48K interleaved F32, but and 2 channels. But the audio card might be different, right? So if the audio card is different, then you can't just dump immediately into the audio card buffer. You need some intermediate thing. So I'm thinking that maybe this function should basically be like generic or something. I think I'm missing context of what you're making here. I'm basically making, we call it D2. It's like a temporary name. It's like, a project code name, not the official name. But it's a chat application that allows you to chat, do calls, screen share, and it's self-hostable. The idea is that, it's annoying when you're always depending on a software, somebody else's platform, and then they keep fucking with it. And then after a while, it goes it shittifies or goes down weird paths, and then you're left with nothing. So the idea is, let's make our own. Let's make it self-hostable. There are some other solutions, like there are some other things like there's Revolt Chat, for example. The problem is, with all due respect to the Revolt people, which, by the way, Revolt is, I believe, as is, way far ahead, much further ahead than where we are right now with this project. But it's like, you want to self-host this? Yeah, here's your Docker container. Here's your spin up Mongo. Well, I don't know if they do use Mongo, but they have a ton of things going on. None of that shit. Single executable, SQLite, so like embedded database, nothing else. Or if it really has to be something else, it's because you really need it. It's not just a nice to have. It's fundamental. If it's not fundamental, we don't have it. So that's what we're trying to do with this thing. So imagine like a single executable that you self-host, that contains everything out of the box. No weird like management things where, oh no, my container is crashing, pooping itself. Why? Impossible to know. None of that stuff. So yeah. Discord Lightbox as wasm plugins server side. Holy shit. You know what? That's honestly not a bad idea. That's actually a genuinely awesome way of implementing stuff like bots. Probably requires you to reinvent the wheel a little bit, right? Because you basically need to invent your own tiny OS that manages processes and that kind of stuff. But why not? Okay, so the idea is that we call read. Yeah, I think that this is fucking great. We make this parametric, and then we basically invoke it behind an inline else, and that way we have all the concrete version of this stuff. Where if it's if all the settings match, then if all the settings match, then you just immediately write to the buffer. If the settings don't match, then you need to have some other setting. Whether you're thinking in terms of persistence, SQLite. Yeah, that part is actually so easy and trivial. Just SQLite. And it's good enough. Also, imagine that this is self-hosted, right? So not one of these things is not designed to, it doesn't have to support like, I don't know, web scale stuff. It's just one community's activity, which is what, like, imagine like a big community, like a very big one. What do you have? 1 message per second? That seems already way too much. Maybe you have a very big one and you have a lot of activity in a lot of different channels. 5 messages per second. That's already like insane, I think. So yeah, so in the end, SQLite is like total overkill. So as it turns interleaved, sample rate. Oh, oh shit. Well, there we go. No, actually, I think this doesn't even need to be on multiple lines. So format has these three guys. Let's give also something else to format. Oh wait, sample type. What's in sample type? It's an enum. Native gives you a type for it. Yeah. Okay, let's see if that works. Does that make sense? Yes, it does. Depending on the audio format, that's the type of samples that you're giving us. Okay, these are checks that help us at some point avoid crashing at random for no reason. When the settings go out of sync and we don't realize that. Okay, that's actually fucking great. I guess we can call it output format. So that it's clear. This is the output format. Okay, then. For now, we are asserting that everything matches. And so we have the simplistic implementation. Like to do implement here format conversions. Then here we do the simple version where we say, well, I guess this is going to be super easy. Like this is going to be playout buffer dot samples dot read first. Reads first length bytes right into destination. We want to read into samples. Oh, there's now a problem though. This speaks bytes. We don't speak bytes here. So we need to look at those samples in a different way. Why is the STD ring buffer byte only? That's how they implemented it. Technically, it could be made generic, but they never did that. You could do it, but honestly, Like none of these things has any overhead. It's like it's just making it a little bit more annoying for the type system to deal with, for you to massage the conversions so that they make sense for the type system. That's kind of it. Now we need to decide how much to read. And we want to read basically the minimum value between what this guy wants and what we have available. Maybe we should rename this to OutPCM. Okay, this seems on point. Now we need to invoke this function correctly. Although, wait a second. No, you know what? Let's not make this comp time. Let's make this slice of U8s no matter what. So that we don't need to do this. Yeah, actually everything becomes much simpler if we just do this. This doesn't have to be comp time. This can be a runtime at this point. So yeah, everything is so much better now. Yeah, we should just talk in terms of byte slices whenever we talk about samples. Yeah. Okay, now we need to worry about where it's invoked, right? Because, or more. Opus packets, no Opus packets structs, right. This is now samples. And how big should this guy be? Right. Now we need to decide how big this guy should be. What did we do for the other one? For the microphone, we did decide on a size in a different way. We use something like this. Capture format. No, okay, so this playback buffer contains Opus data. We want to encode this to like a window size. We want, like, let's say that we want a buffer worth of 250 milliseconds worth of data. So like that's going to be 250 times 1 millisecond. Or we know how big 10 milliseconds are actually. So we can do that times 25, I guess. Well, times 25. Is that it? No. Sample buff size. Times sample size. Okay. Okay, what's the next problem? Right, so this function doesn't exist anymore. This is now all different. So this is all different, and I think this can all be simplified dramatically. because we don't need I think most of these. So let me see. So we have the frame length. Written is going to be but we need this guy. And then written is going to be layout buffer dot read. I think it's stream.format, right? Yeah. Also, why do we need to try this? What could fail? Actually, nothing could fail. So no that, no try. So that's written. That's basically replacing all of this. Oh, yes. This is so nice now. I think that everything found its place. Now, what does written tell us? Oh, here's the problem. So this is in bytes. This is bytes written, which is not what we want to know. So I guess we want to do how much it was read divided by channel count. So what do we want to speak as? What's your unit or measure? Samples, frames, written. Probably should use frames. Frames written. Okay, let's speak in frames then. Although, wait, no, this is wrong because we can speak in frames written, but if we do, then they have to do math to obtain the actual offset. Yeah, let's say bytes written. So if, and so we can simplify this, if bytes written is lower than buffer. Oh, this guy doesn't have, it's not a slice. Get frame len. The fact that this is like just a pointer without a length is driving me nuts. Like it's so much more safe, I think, to pass around slices and just speak in whatever is natural for that thing. And I don't know, maybe either you recompute or you pass around a second value for the other things. But for what we did up above, it worked out really well to just speak in byte buffers. Like whenever you have things that could be different file formats, different, yeah, like it could be float32, i16, or whatever. Just degrade everything to bytes and everything works out nice, I think. You have to do some a little bit of extra math, though. That is true. But I guess you can pointer cast to your preferred type at that point. This seems a little bit overkill. So I guess the size of this guy is frame length times frame needed. Okay, so our PCM bytes written is what we read into it. If bytes written is lower than out pcm.len, then it means that there's more that we need to put there. Yeah. Why is your head always tilted? I don't know. Why is my head always tilted? They draw me like this. I don't know, man. Why is your head always tilted? Uh, so let's just do our logging, not std logging. Let's do inserting frames of silence. Okay. So let's do the like remaining slice. Well, actually, we can do it like this. So length divided um by we need all the audio stuff, right? So remaining frames. Remaining frames is gonna be remaining len divided by stream format sample. Oh, we have a get frame len. That's what we want. Okay, that should tell us how many frames are remaining. And then we just want to memset remaining to 0. That's it. You already have the const frame len. Oh, you're right. Okay, this makes sense to me. What's the problem now? Excited type float 32 found that you ate. Yeah. Okay, let's think about this for a moment more. So we're receiving media from the network. We are decoding it into frames. These are going to be always float 32 frames. So these are always going to be float 32 frames. So maybe we might as well make these float 32 array. And then we do that. Right? Because write accepts bytes. Oh, and then we have this stuff that needs to be updated. Okay. Still unhappy? Value of type usize ignored. Oh, yeah, no. That was kind of important. Type client out sample type does not support field access. Okay, now the question is, will this work? So any math error that I made anywhere is going to fuck up the audio horribly. But let's see. Test. Okay. We're not hearing anything back. That's, I guess, kind of bad. Also, this thing never stops. That's annoying. But if you kill the server, then it stops. Okay, this seems completely starved. Inserting silence. This keeps inserting silence because it never seems to be receiving what it needs to receive. Let me see if that was like something to do with the server. Sometimes the server craps out. Oh, yeah. That was definitely the server. But as you can hear, I'm not doing a good job. Test. Test, test, test. Okay. So we broke it. We kind of broke it. Let's go back to the music. How is it rendered? I'm using DVUI. If you haven't seen it, it's a pretty cool project. It's immediate mode UI made in Zig. So, okay, we're messing up some math. And I think I know what it might be. So I'm now forgetting. For a brief moment, I think I forgot But actually, something speaks in frames, not in bytes. This guy speaks in not in samples. This speaks in frames. So how do we do this? Hmm. Okay, I just think that this guy needs to reply times 2. That's it. God fucking damn it. Happy now? Yeah, this is great advice. But I think test. Oh, I think I know what it is. This is the server that corrupts itself. Okay, let me restart the server. Probably also should fix the server so that it works. Bro, you're good? Yeah. Test. There we go. And it works. Nice. So we're going over the network and we're not losing shit. So, holy shit, this sounds really good. Success. We did it. I didn't have to implement my like a wait before playing thing. Apparently, it like kind of naturally goes in sync. At least with this, local testing. It's beautiful. At least as long as it lasted. Why is there the delay? Oh man, everything that you're doing with audio, where audio is going around in your computer, has some delay. Are you serving on a server? Yes, it's a local one. It's on my same computer, but it is a server. So I'm capturing audio from the microphone, converting it to Opus, sending it to the server. The server sends it back. We decode it from Opus. We put it in a ring buffer, and then we read from the ring buffer into the audio card on a fixed schedule. All of this stuff introduces delay. It sounds like there's a bit of a stereo widening effect. Do you have audio filters in streaming different from the stream? Yes, I totally do. I have a bunch of filters that are running on OBS that basically process what you're hearing from the stream. And then I have that same microphone connected. The audio card that I have can be connected to 2 computers. So the same microphone is being also connected to the Mac, but it doesn't have the audio filters that you're hearing from OBS. So that's probably the source of difference. By the way, this thing that Opus returns you the number of frames was driving me insane yesterday, because the docs don't say that they return the number of frames. They actually say the number of samples, I think, or bytes. They say anything except the fucking number of frames, and that's the thing that they return. And I was going insane yesterday. So that said, I don't know if you noticed, but at some point this thing crashes. It crashed earlier, and apparently it just faulted. Wait, really? We just straight up faulted here? Usually we get a message. So usually the thing that we do wrong is that we send a packet that is too big um over SRT. Maybe we can also go fix that. Did you fix the docs after that? Which docs? After what? You mean the Opus docs? I mean, no. If you're asking, like, did I send a PR? I did not. So SRT thread, media receive, media send. There we go. Oh, I don't have the echo. The echo. Test. Okay. Let's see if it works. Okay, I'm gonna lower the volume so you don't hear echo. But let's see if it works for a while and it doesn't crash. I think that the previous crash that we were experiencing was because I had a wrong maximum packet size for SRT set to the wrong value, and I think that that's what was causing problems, or not. Payload size. Okay, so we have this. Oh, right. We need to homogenize this everywhere. Okay, so this SRT thing here doesn't actually belong here. We want this inside SRT itself. There we go. Now let's go into the server. And let's apply the same fix. So in the server, here's what's going on. When we are processing our queue, oh, it's in media. When we're processing our queue, we're appending master messages, and then here's what we're saying. Let's see. Socket write, iterator, stock.send message, message data const slice. Wait a second. Wait a second. What's going on here? We're sending one message at a time. Let's print the message length as we're about to send it. I'm weirded out by this because I would expect those messages to always be very small. We're sending also them one at a time. We don't even attempt to group them together. Test. Okay. Let's watch it play. Oh, but you see that it's always very small. Right. Like we're sending always, which is correct. Only very, like just a few bytes. Also, you can see 129 is silence. And different numbers depends on, well, the other numbers depend on exactly what I'm saying, which is interesting also that some packets are smaller than silence when, yeah, some are say are like less than 129, but with content in them. Now, why is this not crashing? God damn it. Yeah, I wish I knew what I did to to make it crash the other time. God damn it. Ugh. I don't know. Like, I don't know. Why was that a problem, man? Okay, to be fair, I forgot to like rebuild or something or to restart something, and that's why it crashed. Because the crash was 100% us misusing an API, trying to send a message that was just too big. But this is not happening anymore. Hmm. Test. Okay, I guess we fixed it. Oh, god damn it. No, we didn't. Sending 10,922 bytes. Yeah, no, there's no fucking way. How? How do we get in that situation? What the heck? Okay, on the sending side, we are guaranteed to never have that happen. Oh, wait a second. Sock read. Oh, that's actually smaller. Message size. So when we send, we always send the appropriate amount, I think. Oh, this is the server. Also, never mind the server. Yeah, so client is always sending small data. So there must be something wrong in the server. Some race condition that causes us to read undefined memory or something like this. I guess we can take a look at that next. There's some concurrency problem in here, necessarily. So, yeah, maybe give me a sec. I'll take a quick short break, and then I'll be right back. And then we can look into that. But yeah, this was a very nice change. Basically, we went from stuff kind of working but not quite to, yeah, no, now it's actually way more solid, even with us doing anything particularly smart about it, even. Okay, here back. Okay, I have tea warming up. So what were we saying? So we got everything working, right? No, right. We got everything working except this guy. Right, we have some kind of error condition where everything works fine until it does not anymore. So we have this error that fails to send, and then we even have a seg fault after that. So what I'm thinking is, well, things clearly go to shit when that happens, and I think that we're seg faulting because I think we're basically dealing with garbage data at that point, and that's what's causing everything. Hey, Christoph, did you update to macOS Sequoia? No, I did not. The only thing I know is that it's always a bad idea to update too early. And then every time there's a new version of macOS, none of the features that they add I care about. So, like, I'm definitely not in a rush to update because every time you update, basically stuff that was working before now it's gonna break in weird ways, and all the new stuff, none of it I care about. So, I'm definitely not in a rush to update. That's for sure. That is for sure. Okay. Yeah, let's get this bug fixed then in the server. This is gonna be such a nice commit. I think we cleaned up stuff. Like we everything got strictly improved over before. Oh, you know also what? This guy can be deleted as well. Okay, I'll go get my team. Be right back. Hey, let's go. Let us fucking go. I think we need to run the server in a debugger. That's I feel like that's the move. Yeah. 1315 is too small for the maximum possible 1316. Okay. The server kind of died right away because I changed something, but also where did I do that? Message size 1316. Okay, right. So right. Okay. Let's think about it for a moment. We're in the server. And we are reading from the network. And we are reading from the network. And we're saying we want to reserve 1 byte to put our stuff in there. But by doing so, this guy's annoyed because he thinks that he might want to read that much. How do we do this then? I guess we can do +1. So we can make it slightly bigger. But that's still a problem though. We basically need to guarantee that the client actually uses 1 less byte. That's the problem. Okay. So we make this bigger, I guess, to make this guy happy. But then we need to kind of like check that the numbers match. If the message that we received occupies the full length, then we need to complain. Continue. Okay, in the client, media send, we actually want it to be slightly smaller. Okay. Test. Okay. So now we're running, except we still have that bug. Yeah. I'm going to lower the volume of music temporarily. So, yeah, I don't know. I guess we'll have to wait until that thing triggers. Guess what? It's never going to trigger in the debugger. That happens sometimes. So I guess we might want to do some, I don't know, manual scanning, manual manual overview of the code while we wait. So let's see. We start the SRT thread. For every connection, we create 2 threads, one for reading, one for writing. The read socket keeps reading from the network. There's a pool, and it asks to the pool to create an item. Also, I bet you that the fucking pool is not synchronized in any way. It's on me to synchronize it. Yeah, it doesn't have any socket or anything. So yeah, create those stuff with the pool. Destroy those stuff with the pool. So probably this is what we need to do. We need to protect it somehow. Mm-mm-mm-mm. Oh, we did crash in the meantime. And then we crash in item.next. Yeah. I mean, the fact that this is a bad access is this is 100% a concurrency bug. Okay, I think we found our problem. I guess we do get pool. Also, how do you like release it? Oh, right. That's annoying. I guess we could do it manually. We're not really using the pool in that many places. We're using the pool like only when creating, when destroying, and it's like that happens in only 2 places. You know what? Let's not have this abstraction. Like let's not do abstraction. Let's just go. Let's just do the thing for now. Okay, so whenever we want to call pool create, we lock. Mm, maybe we can create a function that can help with that. It's pool.create, right? How does it work? Yeah, I think that's kind of it, basically. So instead of calling the pool directly, we call message.create. Okay, let's see if we can make it crash now. Test. Okay, so still working. We didn't break it. So I don't know. I guess I can leave it there for a while. If we fix this, I think it's time to make a commit. So it seems that it fixed now, I guess. Maybe. So it's kind of crazy actually how well this works. Yeah. Maybe we could induce some jitter artificially and see what that causes to happen. Okay, I'll assume that everything works. Actually, if I reconnect, will it still work or will it poop itself? Test. Okay, no, it does. So the server, if you disconnect, it totally poops itself forever. Let's fix that. Okay, what's going on here? Here we're doing things. Oh, you know what's? I know what's going on. You should see what happens if you receive out of order. I don't receive out of order. So Neurosite, you since you're familiar with this stuff, take a look at what SRT does. Don't look at SRT, the website, because that's full of bullshit. Look at the repository. I'll link it in chat. Hey, Jackie Valley's hello. So so basically this is like UDP, but it handles a bunch of stuff for you. It even has like it automatically does like trying to resend things. There's a bunch of stuff. Actually, most of the API I don't know how to use, if I have to be honest. But it's basically like I understand that what I'm already using is like the fact that it's like fake TCP over UDP. So no out of order. It also tells you whenever it knows because of timestamps and settings that I don't know how to set. That, well, I guess we are basically inheriting the defaults of. It has a concept of like how much like what the buffering window should be, so it knows how how long to retry for things and when to give up and accept that the packet was lost, that kind of stuff. So it's pretty cool. I don't know if this is something that we should have forever, but as a starting point, I think it's like it's a pretty decent starting point at the very least, I think. Does it help handling jitter somehow too? I believe so. They have some information about that. I don't know exactly how they make it sound super amazing. So I don't know how good that actually is past what they advertise. But let me see where I can find that information. Oh God, is that a PDF? But basically what they do is that they ensure that they basically, the thing buffers. It doesn't give you packets as soon as they arrive. They give you packets at a regular interval when they are supposed to be arriving. And so through that, they also basically, I don't know, amortize jitter, at least in theory. So I don't know. You can read in here how it's supposed to work. But yeah, I think it's like shown here, right? So source produces samples at a fixed rate. Network transmission has all kinds of jitter and stuff. So this transmission is very regular. But then on the other hand, there's like a receiver buffer, which I guess is what compensates for that. It will fix jitter just by dynamically adding latency. Yeah. And so, yeah, I think that's how it works. So I don't know. That's what we're working with for now. What are we working on network audio for? What's the parent project? We call it D2. It's a code name. It's not the actual official name of this thing. It's chat application. There's like a bit of a GUI implemented, and yeah, and you can join calls and hear yourself whenever the server is not pooping itself. Right now, the server is pooping itself, so let's make it not poop itself. What is the GUI written in? I'm using DVUI. Okay, so on startup, does your payback thread block on buffer underflow? On buffer underflow, we play silence in a very unsophisticated manner, like literally going from wherever we were, like whatever amplitude we were at, to silence. And we keep playing silence. I know that we should do better, but I don't know how precisely. I have a vague understanding of, well, the problem is you could be underflowing, you could be overflowing, you could be slowly drifting back in time. So like your buffer starts filling, and then you're basically gaining latency over real time, and that's not good either. Or maybe you gain that that happens not slowly, but because of, I don't know, like your system hangs for half a second, so that's where you gain that. So I know that these problems are there. I don't know how to fix them, or rather, I mean, I don't have the answer right available to me, but I guess it's just a matter of sitting down and thinking that stuff through. Also, if you have pointers on how this stuff is normally done, I would love to hear, like to read some documentation on that. So we don't block, we just play silence. And I know that there are also alternative strategies, like, for example, speeding up the the playback a little bit. That is something that could be investigated. Personally, I fucking hate that. I personally really despise when tools start playing faster. I would always, no discussion, always take the like skip ahead, skip some audio, man. Please skip some fucking audio. No, don't give me that shit. So that's my take on that. Also, so I mentioned that right now I'm using SRT in a very naive way. I'm using, you can see it here, for example. I'm using the send message API, and send message is, well, right now I'm even wrapping it in a very naive way. So I'm using send message too, which allows you to send a message. So SRT is also like, how can I say, is framed. So you send discrete messages and receive discrete messages. And what did I want to say? Yeah, you send and receive discrete messages. And there's another optional thing that you can pass in. Like this is like a out pointer where it can tell you metadata about the packet. And one piece of metadata that you receive for every packet is the send time, the time at which the packet was sent, so that you can use that. I'm guessing. I think there's also like a sequence number. I don't know. Well, there is one. I don't know if you can access it. But at the very least, you should be able to tell when a packet is like late, when a packet is lost. Also, I think I would have to double check on that last one. But point being, that is also information that could be used to decide what to do whenever the network is going it's going fuck. Yeah, but I need to learn how to do this stuff. So basically that would require to change the signature. We're going to do video 2, right? Yeah, that's the plan. I guess first we need to master audio before we can adventure into video. We try to get also screen capture working and made some progress there too, but there's a lot of OS integration as well that need to happen there. Skipping audio could result in unwanted pops. Well, then the nice version of skipping audio is that you don't just skip audio, but you skip audio and you also smooth out the transition. So whenever you do something like that, you know that you're doing something like that, and then I don't know what the word for it is, but you apply some kind of convolution to, I guess you need to remember the last few frames, the last few samples that you sent out. And so you know where you're starting from, you know where you need to go, and then you can make it smooth. That's how you avoid pops and stuff. Yeah, by the way, video is probably also its own like kind of worms. It's like audio, just worse, probably. So we'll have to see what to do there as well. I am a little bit regretting maybe not choosing to go with something like WebRTC just to get more stuff off the ground faster. But I think there's also a lot of value in learning this stuff. I somehow suspect that WebRTC is not doing the best. It's not making the best choices everywhere. So it can get pretty ugly with video, especially trying to keep video and audio in sync if you have jitter and or packet loss. Ooh. I think that that's where SRT comes in like handy. Probably. Yeah. But to answer the question fully, I would need to learn more about how to use the SRT API. So baby steps. Okay, let's see if we can unfuck the server whenever we disconnect. Most obvious advantage of WebRTC would be a web client, I guess. I guess WebSockets with this proto would work too. So yeah, normally, I guess that, yeah, if you're doing web, you need to do WebRTC. But I think that also with WebRTC, you can have, how can I say? You can send WebRTC data. Like you can set up, I think, a WebRTC connection, but then not really do proper WebRTC, but do your own thing within the framework of WebRTC. And so my hope is basically to be able to do something like this. That said, right now, for web is honestly the platform that I care the least about. I understand that there are obvious advantages in, well, okay, you want to support as many platforms as you can. Web is obviously a very important platform, but also I think that for this project to make any sense, for it to be, be not yet another half-assed rewrite of what's already out there, I think it shouldn't be, it should like be web last, not web first. There's already plenty of things that, they start with web and then you want native and you get, and, we have native at home and that's like a fucking Electron. So I would like to avoid that. I would like to optimize for what you can do with native, and then web gets whatever they get at some point in the future. In the end, like I feel like that this obviously needs to support at least the 3 big OSs for sure. Mobile is also kind of important, at least for messaging. But past that, I don't care about web because sure, that could help with adoption. People could try it more easily, but also like seriously, I feel like this from my heart. It's like, fuck the web for this stuff. What I'm planning actually is to basically, but DVUI is nice because it can also work for WebGL. So you can make a WebAssembly build of your program, and DVUI renders in a WebGL like this where you're seeing here. This is not the DOM. I am selecting text, but this text selection is implemented by DVUI. So I cannot right click. I'm right clicking, does nothing. This is not the DOM. This is one canvas. And in there, DVUI can render everything. So so technically we could build D2 WebAssembly plus WebGL and have that run in the browser. There are some caveats if we actually wanted to pull this off right now, because well, Opus would need to build for WebAssembly. So we would need to figure out how to do that. SRT would need to build for WebAssembly, or we would need to use a different transport. And so we would have to make that work as well. I'm using libxcv from Michel Hashimoto, like the it's a Zig native libvuv alternative. That one also has trouble with WebAssembly, although it's not necessarily its fault. It's because it's trying to do evented IO, and evented IO doesn't work super great on WebAssembly. So that's another practical problem if we wanted to go down that route. But yeah. I remember having real issues building Opus for WASM and just went with Vorbis. God fucking damn it. Maybe it's better nowadays. I don't know. So with the help of Johnny Marler, we packaged Opus for All Your Codebase. And by the way, if anybody here is not familiar with All Your Codebase, that's an organization that I opened on GitHub to basically collect Zig.build files for C and C++ projects. So basically to make them more accessible to Zig users. And so, for example, Opus was added because I needed it. So building Opus is very simple with a build.zig file. But it does have, I think, 2 main problems. One is dependency on libc, which is kind of sucky on WebAssembly. And then the second problem is that I think it tries to sneak in assembly here and there. And I think that some of these assembly things can be toggled off. And so you can get a build working, which is maybe not, maximally optimized, but you should get something working. But I haven't attempted. I just noticed that there are some files that have like that implement like more optimized things specific to different platforms, x86, 64, ARM, etc. Yeah, but I'm not sure. Okay, so what we're looking at, we're trying to make sense of what's happening in, not here, but in server media. Okay, so we accept forever. Whenever we accept, we create a new connection and we append it to our list of connections. Yeah. Then we start 2 threads. Oh, and we join them. Interesting. We even wait for those threads. So it means that this is currently what? Why there is no STB Opus? As the author of STB Vorbis, a noteworthy software implementation of OGG Vorbis, which is available in the freest possible license, public domain where available, and used by some non-insignificant number of game developers and other software developers, I'm occasionally asked, when will Opus be released? The answer is never, as things currently stand. Let's go. Oh, this is like 10 years ago. Let's fucking go. Orbis is an audio codec created by zif.org and released in 2000. Opus is an audio codec specification released by the IETF in 2012, based on combining 2 independent codecs, a non-Vorbis codec invented by zif.org and Silk invented by Skype Limited. Oh yeah, I remember building... okay, now I know what Silk is. I remember having to build a Silk sub-project. Opus appears to be superior to OGG Vorbis in many important ways. One of significance to game developers is that Vorbis has a substantially sized header which contains the code tables. This storage cost is insignificant on long files but substantial on short files. This means that using OGG Vorbis, sound effects which are normally stored 1 sound effect per file is significantly space inefficient due to the many redundant tables. For these reasons, creating a SDB Opus library is a compelling proposition. I would like to create an SDB Opus. I think it would be useful. Why this is not going to happen owes to the nature of the Opus specification. And for this to make sense, you will need a little educational background about copyright. Oh god. Okay, if I create work, a program, novel, piece of music, which incorporates elements of some copyrighted work, the work I create is a derivative work. It derives from the original work. The legal status of a derivative work in the United States is that it is essentially also covered by the copyright of the original work. That is, it's really covered by the copyright of the original and a second new copyright for the derivative work. Copies can only be made with permission of the owners of both copyrights. I can't sell my Harry Potter fanfiction without J.K. Rowling's permission, but she can't sell my Potter fanfiction without my permission either. The software libraries I've created, like STB, Vortis, and JPEG, are not covered by any of the copyrights, by any other copyright than my own. This frees me to disclaim my copyright and to place the libraries in the public domain where dedication is legally allowed. However, I can't take somebody else's software and make some modifications to it and place the final software in the public domain. I can make my modifications public domain, but they're, of course, useless without the original software, which is still covered by the original copyright. Now, I did implement SDB Vorbis and SDB JPEG from specifications documents that describe in plain English what the behavior of the software is supposed to be, even though that plain English description may explain very mechanically what the software is supposed to do. Legal doctrine, at least as far as I understand the legal doctrine in the United States, does not recognize an implementation from specification as copying from that specification. The implementation of software from a plain English specification is not derivative work of the specification. The software is not contaminated by the copyright on the specification. As a result, when I disclaim copyright on that software, I know the only potential copyright that would have applied is my own, and thus my renunciation of the copyright is meaningful. Can I create software that's uncontaminated by any other copyright so I can make it public domain? Yes. Reverse engineering. The United States has a legally recognized method of reproducing the function of another system without violating the copyrights or trade secrets of that thing. The method is called as clean room reverse engineering. In this process, one team of experts closely analyzes the copyrighted system to be re-implemented and constructs a plain English description of the behavior of the system, i.e. an independently constructed specification. Then a second team of experts with no other communication with the first team, then reading the specification, implements the specification. Hopefully, at the end, the second team will have constructed a functioning clone of the original system, and this process guarantees that the resulting clone is not a derivative work of the copyright in the copyright sense. Thus, if I wanted to create a public domain clone of a system for which I do not have a plain English specification, I could use the above process and implement that. This process, however, is expensive, and it's not something I'm actually likely to do with my own time and money. Opus specification copyright. Unfortunately, the Opus specification is not plain English. Whereas many other specifications have a language like if the reference code and the specification deviate, the specification is correct. Opus has chosen the opposite. Only the reference implementation is normative. Moreover, the plain English explanation for it is apparently incomplete. While the symbolic representation is unambiguous and complete, it is not always the easiest way to understand the codec's operation. For this reason, this document also describes a significant part of the codec in prose. No implementation of Opus from the specification can proceed from a plain English description of the algorithm. There is no complete correct one, and so any such implementation must derive from code elements. What is the copyright status of a new implementation derived from those code elements? Well, those code elements are themselves copyrighted. Here's the copyright notice. Okay, so the simplified BSD license is a kind of open source license which allows derivative works to be copied without explicit permission from the original copyright holder. The license grants the creator of the derivative work the freedom to copy given certain limitations. For example, they require acknowledgement of the original authorship of code elements, both in source code and materials accompanying the library. Okay, so I think I'm following for now, but this doesn't explain why this person doesn't want to make another implementation of this stuff, other than they really don't like BSD enough. They think that BSD is not enough, and they really, really want to have the thing be public domain, period. Which, I mean, I guess might be a thing, but I'm not sure if that's the case, I'm not sure I follow, like, whatever, like BSD is already good enough. Who cares? So I hope to read an explanation on why is it worth to renounce. Also, I'm assuming that an SDB reimplementation is not just public domain. It would also be in some ways better mechanically, because otherwise, if it's the same, like, I don't know what the state of SDB Vorbis and SDB JPEG is, but I'm hoping that they are better than the official implementations, ? Because if they're not, then what even the fuck is the point? Unless those things have very weird licenses, then I could understand. But BSD seems as tame as they come. So, okay, let's see. This license is clearly what applies if the code elements from the specification are copied directly, since they are clearly covered by the copyright on that code. If the new code is a paraphrase or inspired by the other code, the copyright status is unclear to me. I do not claim to be an expert in the subject area, just need enough knowledge to know where I can legitimately place something in public domain, blah, 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 blah. They are one-file implementations for very easy to use, especially popular for game developers. Okay, That is the technical advantage I see. So I would say that one file implementation, man, that shit needs to die. I get it. I get that if you're doing C, one file means, holy shit, I will not have to deal with any stupid as fuck build system. That is fair. But that's like, that is time to go. It's like, this is the, I get it. But now we're at a point in time where we're forcefully squeezing an entire thing into one file. Doesn't matter, shouldn't matter anymore. So now like just use the Zig build system, man, and live a good life. So I feel like that I'm personally, I feel like I'm not, well, hostile is a very strong word, not hostile, but like I get that one file was a thing. It shouldn't be a thing anymore. That's not, shouldn't be like a thing anymore. That said, for example, if the STB version would build for WebAssembly trivially, and the other one doesn't, then yeah, that might be interesting. But at the same time, it's like it's cross fucking compilation, so it's not impossible to make happen. Okay, but thank you. I'm starting to get like the picture. By the way, this is maybe stuff that people should know, like what nothings.org is. I don't know shit, so thank you for giving me an opportunity to learn more stuff. If we need the copyright status to be clearly not affected by the copyright of the original code, blah, 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 then we have one mechanism that I'm aware of. Wait, did I scroll up? No. Clean room reverse engineering. Of course, the process of clean room engineering is basically just the process of creating a non-planar. Okay, that's the same thing as explained as before. As a result, I cannot create a public domain STB Opus unless one of the following occurs. If you want to take steps to see an STB Opus, I don't know, like, man, what's the problem with a BSD STB Opus? Just relax, man. I'm sorry. I feel like people, with all due respect, by the way, okay, let me start with this. I would have no idea where to start implementing my own single file Vorbis in C or my own single file JPEG in C. Okay, so enormous respect for this person. That said, I don't understand what is the problem of going bonkers over these license stuff. At some point, it seems religious. There's like, it becomes a thing where it has, past a certain point, it has close to zero practical implications, practical like advantages being one way or the other. And so it's like, whatever, man. Why hyper focusing on it? Oh, here's the reasoning. Okay. Why is this library public domain? Because more people will use it. Because it's not viral, people are not obligated to give back. So you could argue that it hurts the development of it. And then because it doesn't develop as well, it's not as good. And then because it's not as good, in the long run, maybe fewer people will use it. I have a total respect for that opinion, but I just don't believe it myself for my software. I mean, that's fine. Like, I can totally understand an appreciation for public domain over any other library. Like you think that that's better and that's what you would like for software that you make to be, great. But by the way, it's not entirely clear what happens for places that don't have public domain. Like for places that don't have public domain, then what is the legal situation of people that want to use that stuff? That's another interesting question. So if at the end of the day, your public domain thing can practically be used by fewer people than if it were MIT because they don't have public domain in their country, that seems to me, it's kind of like, I don't know, it's paradoxical in a sense. It's like peak irony. But then it's like, if the viral license, all the viral license is doing is saying that it's like you need to keep around the name of the person who implemented the original thing. It's like, oh my God, it's whatever. Just leave the fucking license file somewhere. Nobody gives a shit anyway. So as long as it's easy for me to cross compile. Yeah, fair. I mean, I would agree. Public domain versus attribution required licenses. The primary difference between public domain and say CC or BSDs, while I would appreciate acknowledgement and attribution, I believe it is foolish to place a legal encumberment on the software solely to get attribution. Fair, but at the same time, whatever, man. In other words, I'm arguing that PD is superior to BSD and Creative Commons attribution, fine. If the license offers anything besides attribution, as it does, blah, 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 that's a separate discussion. Okay, other aspects of BSD style licenses besides attribution. Yeah, I mean, okay, I'm not gonna read this part, but I get it. Like, if they're already not happy with just having to repeat the name, then anything else that you ask they don't want to do, that's fine. I just feel like, I don't know. Having games be better at doing audio in my lifespan, to me, seems more worthwhile than than forcefully only using the best, the license that I consider the best possible one. I want more games. I don't want more pieces of text to say one way or another. Like, whatever, man. Who really gives a shit? Okay. So here we're doing connections. Here we are doing connections. I don't think we should join them. We don't join them. We just launch those threads in outer space. And then and I guess we can have read fail on read failure. But then read should also disconnect the connection from our list of connections. Right, we start from the head. It's a pointer. I lost it. I think it's a pointer to an optional connection. So we start with that. So while cur.star is a connection, this is the fancy way I think of disconnecting things from a linked list. This is my first time writing it. I don't know. I don't have strong opinions. I thought it was funny. People seem to have very strong opinions about this stuff, which is another funny thing. Okay, so we go there and we say, if this thing is us, this is us, then we want to set that. Is it dot star? Wait a second. So we get a pointer to a connection. We want to set that. So we want to set cur.star to us.next. And then we want to set core. So we want to move that to our next. Do we have also prevs in here? We also have prev. And then I guess we say that if we did have an next, what do we set that to? To our prev. I think that's how it is. So we start from head. If we are the head, then we set head to our next, which is if we were the only one, then that gets set to null, and then we're done. If we did have something afterwards, then we set that to our prev, which could be null if we were the head, or if we were not the head, it's going to be something else. Okay, so let's say that we are not the head. So the head is some other node. We continue to its next. If that's us, then we're now centered over the next field of the previous connection. If it's us, then we move it forward, and the other thing gets moved backwards. Okay, that seems perfect. So this should disconnect us from the linked list, which is good. We should protect that stuff atomically. We're not protecting this atomically, so we should probably like have some kind of mutex here that we grab. Yeah, but we don't. For now, it's fine because we only have one connection going on. So totally an improvement that we need to make, but this should not be the source of our breakages right now. Well, let's see how that goes. Test. 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 Okay. So we are connecting multiple times correctly. The receive error connection was broken. Yeah, that's fine. We close the server, the client, I mean. We reopen it. Test. Okay, now the server doesn't poop itself anymore. And everything is beautiful. Huh. Okay. Hey, Stevie. Guess who's speaking to themselves through Opus and a local connection? That's me and myself. So yeah, I got everything working. Test. Woohoo! And yeah, this is going through the network. You can see that here's an interesting thing. Okay, let me lower the volume so that you don't hear as much echo. But silence is 129 bytes per window, 10 milliseconds. Voice varies depending on I guess what I'm saying or what the fuck is going on with the frequencies. But also sometimes voice is less than silence. Like you can see that sometimes some packets go below 129 as I'm speaking. I don't know why, but that's how it is. Is silence Opus encoded? Yeah, currently yes. I think the way it's working right now is that we literally have a bunch of samples all set to 0. We give those to Opus. Opus produces some output, and that gets encoded, sent to the server, and sent back. Yeah. Probably because the silence has a high noise to signal ratio. No, that silence. Oh, I was about to say, no, that silence is complete silence. But I'm actually wrong. No, you're right. I don't have... in this thing, we don't have the concept of a... what do you call it? You know, like the gate thing that it's below which you're in full silence, like a threshold. Yeah, there is no threshold. So you're right. What I consider silence, it's not silence, it's noise. I forgot. My Discord brain. Yeah. So you're right. That's a ton of noise. That explains why that is. So I actually don't know what pure silence looks like and what we are even supposed to do with pure silence. I guess that's gonna be something that we'll have to learn along the way. In any case, as you can see, everything works, doesn't poop itself. Progress. For PCM, silence is usually the middle value of the available bit range, right? Actually, I believe so, yes. We're using float 32, and I believe the float 32 is normalized between -1 and 1. So, well, I say normalized, that might be a strong word. It's centered at 0, goes usually between -1 and 1, but you can have bigger values than that, bigger in magnitude. I assume you could send a start silence packet and then say silent on the network until there's audio again. Maybe. Maybe. Yeah, I think that's something that we need to learn how to do. By the way, if anybody here from the usual people like Neuroside, JerboQ, and well, Stevie is already in there, but like if you guys are interested in D2, let me know. I have a secret next channel for you to join. Especially if you're interested in helping with some of this stuff. It's kind of messy still, but it's getting to a point where people can start contributing a little bit, because this thing is starting to become like very complex in on itself. So like people could start, like if somebody wants to work on audio stuff, they can do so kind of in within that thing. Even if we're making a mess in other parts of the code base. Also, the sun is going down and it's getting reflected on a window and it's like flashing me super fucking hard. So that's why I'm weirdly colored. I guess it's getting somewhat cinematic. So that from the network gets decoded directly by the network thread and stored as PCM data, PCM samples in the playout ring buffer. Then, what else did we change? So playout buffered already is where Opus, where F32, 48K, 2CH, interleaved samples should be converted in case that the audio stream, in case that the playout stream Do we do more than that? Let's see what else do we do. Oh man, so many lines deleted. That is so good. By the way, why don't you just record the silence and send it? Well, that's basically what I'm doing right now. I don't know. I'm assuming that it might be an interesting idea not to do that, but it's not necessarily a good idea. So I don't know. If you generate through silence, it tends to irritate people because they think the signal is cutting in and out. That's why telephones generate comfort noise instead of silence. Yeah, but if you think about what Discord and TeamSpeak and company do, they don't do that. They do give you the full silence. I personally like that. I don't like the fake silence. The fake noise. You do get other visual indicators that tell you whether you're connected or not, right? So personally, the experience that I'm aiming for is something more similar to, like, very close to what you get from, I guess, Discord nowadays. But if you want a non-Discord point of comparison, TeamSpeak. So something like TeamSpeak, not like VoIP tools. That said, we could actually emulate that stuff locally if you really want to have that. Yeah, exactly. That said, maybe there might be other advantages in sending silence data around. But I don't know. I guess, you know what? I'm at a point right now where I think of all these things and I think, oh, it would be cool to do that. And then I have no fucking clue if it's actually a good idea or not. So you want something that sounds like push to talk? Yeah. I would also offer the option to constantly stream. I guess that's basically what you. Okay, so I think there are like two levels here, right? So you could have clients set up that way. Like even in Discord right now, if in Discord you pull the noise gate all the way, not the noise, the noise gate, volume gate. Well, if you put that threshold all the way down, then your microphone will stay open all the time, and all the noise, well, not fake, but like natural noise that comes from your microphone will go through. So as a user, you can configure that in Discord, and I would say you should be able to configure that as well in this other thing. So you should be able to do that. I would expect most people to keep using it though with the other way, where you do have a gate that basically omits super what's the word for it? The opposite of loud, super quiet sound. So there's that. So in a sense, Discord can be operated with constant open stuff if you want to. Just people don't normally do that. And on top of that, then I would say, and regardless of that, if you as a user would like to have comfort noise on whenever you're in a call, then I guess you could enable that locally. And at the same time, I think you wouldn't want those things to sum up the more people you have in your call. So I guess you would want a constant level of comfort noise, not 5 times as much because you have 5 people making fake noise. So yeah, I think that in the sense, like, the future is bright. We can implement all this stuff. Okay, I'm very happy. So I don't know what to do next. I mean, obviously there's more to do. So here's a next step that missing for the server. I think that the server right now, it can echo, but can it actually handle multiple clients? I don't think it can. Let me think for a moment. Actually, so we have this disconnection thing that we should protect. But aside from that, oh, we can actually test this. So this is going to work now because we are not really even though we're the same user, this is not really wired in at all. So we can connect twice. Let's see what happens. Test. Test. Oh. Test, test, test. I'm not sure this is working correctly. Test, test, test. What is going on? Test. Oh, I know what's going on. Okay, I know what's going on. No, there's no noise gate. There is no noise gate. So here's what's going on. There are two streams playing at once, but that's not fully, because if you would hear like reverb, but you wouldn't hear weird artifacts. Is the mixer clipping? No, that's not it either. Or okay, here's what's going on. When I'm connected with more than one client, well, when there is more than one person in a call, keep in mind that we also have echo, right? So you being by yourself, it's almost like being two people. Well, in any case, you hear yourself back, and then you hear the other client also. But the problem is that these are two separate audio streams that are coming to you in parallel. They're not coming to you like, one after the other. They're coming in parallel. And so you would need to tag each one of those audio streams. You need to differentiate them, and you need to have a separated decoder on the client side for each of those. So each thing needs to have its own decoder. And the problem is I don't do that right now. Right now I only have one decoder. So I'm basically sending all the Opus compressed data into one decoder, which kind of hears the same thing twice in a row. But also I'm using the decoder in the wrong way, because the decoder does not expect you to send things that way. And so, long story short, it's fucking up. So there are two options now. Either I myself manage multiple decoders. And by the way, I do have some of that information in the protocol. I'm just not using it correctly. Media. In server media, whenever we send a message, the first byte is the client ID. Does any of this work on Linux yet? It does. Everything that we're using should be is cross-platform. I think that there might be, okay, I haven't run it on Linux in a bit, so there might be some minor problems, but we're using port audio for audio, so you should be able to, so that should work transparently. With the caveat that I guess it depends on how fucked up is your Linux setup for audio. But assuming that you have nothing too complicated, like if you have Pulse Audio or Pipewire, you should be fine. If you have some other stuff, I don't know. And yeah, everything else is portable. So, yep. Actually, Linux users should be welcome, for sure. Okay, so as I was saying, maybe I can show that visually. So visually, here's what's going on. When I'm alone, this is like, let's say, this is my microphone. Okay, well, whatever. Okay, this is my microphone. Goes into Opus. Goes to the network. Server. Gets sent back to us, to the client. Still as Opus. But this is our Opus decoder. And then we decode that, we get PCM. And that goes into our speaker. How do we do the speaker? I don't know, man. Okay, let's speak. Okay, wait. No. We can do better. There we go. Headphones. Okay. This goes in our headphones. So what's the problem then? Then with two clients connected, we basically have a second microphone from another client that does all this stuff, goes into the server, but then we send everything down the one Opus decoder, and that's bad. Yeah, these are the actual icons. Oh yeah. So we do have in the network protocol that for every client we have an ID, we have an identifier that we can use. And the first byte is that value, but guess what we do in the client? Guess what we do in the client? When we media receive, we skip the first byte and we just do not give a fuck about it. That's what happens. So we need to do, I guess, better than that. That said, guess what? Guess what? If you look at the API of Opus, there's Opus multistream.h. Is this the one that contains all the multistream definitions? Yeah. So there are multistream APIs that I guess could be used. So maybe Opus itself can basically give me that. Like, can I do... show me multistream encode. Encoder create. Oh, the problem is that it wants a fixed number of streams. Mapping. Mapping from encoded channels to input channels as described in the ref output multistream. As an extra constraint, the multistream encoder does not allow encoding coupled streams for which one channel is used, since this is never a good idea. Okay. I guess you basically started with the maximum number. So we say that we can have maximum 200 and whatever, 255 people in the same room, max. Opus multi-stream encode float. Okay, let's see how it works. You pass in PCM frame size, data, max data bytes. Wait a second. Where do you say which is the fucking stream? I'm kind of confused. Let's see. Multi-stream encoder state. PCMS float. Frame size. Output payload. I guess the idea is that you're supposed to... I guess you're supposed to put all the samples in parallel or something? Like, what the fuck? I guess dynamically adding and removing people is complicated. So this is the problem. This is the point where you have to ask yourself, what do you want to do? Do you have the server merge all these audio streams together on its end at the PCM level? Like literally you use sum together the samples and then divide them by 2? Like you average them? Question mark? No, you don't. No, you totally do not average them. You just sum them. But then you need to do some normalization. How does that even work? I guess you just sum and call it a day. And then if people are being too loud, well, fuck you. I guess that's how it is. Okay, so then you sum all the samples together, re-encode everything, and then ship over the wire one stream with everything re-encoded in it. I think this has problems though, because we're already, no, the way we're routing right now in the server is that we're not decoding Opus, and we're also leveraging the fact that when Echo is disabled, right now Echo was enabled, but with Echo disabled, you actually want to skip sending to the user their own stuff. So I'm having trouble understanding what the multi-stream what the multi-stream stuff means. Oh shit. That's how it works. Oh, I skipped the macros. But it's the macros that are the juicy part. You create one multi-stream encoder / decoder, but then you don't give a multi-stream encoder decoder to this guy, do you? Wait, okay, let me see the macros. Oh, these are convenience macros specific to encoder CTL and decoder CTL. Okay, so these are just for controlling stuff. Never mind. Get the encoder state for an individual stream of a multi-stream decoder encoder. The multi-stream API allows individual Opus streams to be combined into a single packet, enabling support for up to 255 channels. For individual Opus streams to be combined into a single packet. Unlike an elementary Opus stream, the encoder and decoder must negotiate the channel configuration before the decoder can successfully interpret the data in the packets produced by the encoder. Some basic information, such as packet duration, can be computed without any special negotiation. Multi-stream Opus streams can contain up to 255 elementary Opus streams. This may be either coupled or uncoupled, indicating that the decoder is configured to decode them to either 1 or 2 channels, respectively. The streams are ordered so that all coupled streams appear at the beginning. A mapping table defines which decoded channel I should be used for each input / output IO channel J. This table is typically provided as an unsigned char array. Oh man, all the fucking HTML in the documentation. Each multi-stream packet contains an Opus packet for each stream. And all of the Opus packets in a single multi-stream packet must have the same duration. Therefore, the duration of a multi-stream packet can be extracted from the TOC sequence of the first stream, which is located at the beginning of the packet, just like an elementary Opus stream. I'm not sure this is what we are looking for. Now I'm, now I'm really not so sure about what's going on. Are you doing multi-channel audio already at this stage? Well, not necessarily. So here's what I'm worried about mainly. What to do when you have two guys, when you have two people in two persons in a room. Right now, the server obtains Opus packets from each and literally ferries them around. So individually, completely on their own. So I guess we could keep doing that. And then on the client side, we instantiate a new decoder every time a new packet with a new like client ID shows up. And we basically, keep assigning the same packets to the same decoder ID. But I was wondering if there was any built-in support, and like this multi-stream stuff seems interesting. But at the same time, I'm not sure I understand what multi-stream does. Which is different from the other one. That is the part that I don't understand. I wouldn't couple them at the Opus level. Just let the server forward the Opus streams as is and decode multiple streams on the client. Okay. So that's what I kind of was expecting, to be able to do that. And then having this thing be a convenience on the client side, but it's not. This is something different. It sounds like multi-stream is just a way to decode multiple streams at once, but it doesn't mix them down, which is fine. Yeah. That makes sense, which is fine. But it seems weird. Like, I don't understand what the use case for this thing is, because it seems that it might be something that we could use, but then not quite. So I wasn't necessarily expecting this thing to do the down mixing for me. I was only expecting it to basically save me from having to do the thing where I need to dispatch each packet to the correct decoder by myself. I guess we can implement that next. Although I don't think I have a lot of time remaining today for streaming. I think that it's time for me to go to dinner soon. So maybe, you know what? I'll stop early. I'll stop here. I will do dinner. And maybe I will be back in Discord to continue working on this stuff, just in Legacy Discord. By the way, in your side, I will totally add you to the discussion channel, since you asked me to. I think it's mainly meant for multi-channel audio, like 7.1. But okay, but then tell me, why is this separate? Because the other one, Opus, like non-multi-stream, like this guy supports how many fucking channels you want as well. Oh. Never mind. Never mind. I got it completely wrong. I thought that this guy, you could toss in there as many channels as you wanted. Never fucking mind. This guy is only 1 or 2 channels. Question answered. By the way, there's another thing that I want to experiment with, which is the Dread stuff. So there's a new API, the Dread API, that basically uses a neural network to do forward error correction. And that seems interesting. So basically, I don't know what this thing is based on, like exactly how the thing trains itself or whatever. but that's a different way of doing of dealing with lost packets. And I wonder if this is by any chance superior or what. Like I would be curious to try it out. And I know that WebRTC doesn't have support for any of this shit, so I would be curious. Also, we're using float 32. I don't know. Maybe that's overkill. Maybe we should just use normal int 16 stuff. That would be, I guess, more efficient. Half the bits. But yeah. So in any case, I would love to also discuss this stuff with people that know more. So yeah. Okay. Well, thank you all for hanging out. Let me see if anybody is streaming by any chance. That does not seem to be the case. Yeah. Okay. So I'll call it a day. Thank you all for hanging out.